Good morning, dear students, and welcome back to our today's online class. We are studying about gases laws and in particular Boyle's law. In our previous class, we learned that at a constant temperature, the volume of a given quantity of gas is inversely proportional to its pressure, or in other words, the pressure of a given quantity of gas is inversely proportional to its volume. This is what is stated by Boyle's. And when the initial and final conditions, initial pressure, initial volume, and final pressure and final volumes are compared, we found out that the product of initial pressure and initial volume is constant, and the product of final pressure and final volume is also a constant. Therefore, Boyle's law came to a conclusion that the product of initial pressure and initial volume, which is represented by P1 and V1, is equal to the product of final pressure and final volume, which are represented as P2 and V2. So according to Boyle's law of gases, P1 into V1 is equal to P2 into V2, and this relation is used to solve numericals based on Boyle's law. So let us try to solve few numericals in our today's class. Question number 1. At a particular temperature, a certain quantity of gas occupies a volume of 85 cc. Cc is also equal to centimeter cube at a pressure of 760 millimeter. If the pressure is decreased to 250 mm, what will be the volume of the gas at the same temperature? Now here we need to understand the final condition over here, which is given as decreased to 250 millimeter. So this decreased to means that the final value of pressure is 250 millimeter. Here it is not written that the final pressure is 250 millimeter, but it is given in other way. Over here it is mentioned as decreased to. So let's write the given condition first. So P1 is 760 millimeter and P2 is decreased to pressure, which is 250 millimeter. V1 initial volume is 85 cc, and we need to find out the final volume when the pressure is decreased to 250 millimeter. Now, according to Boyle's law, we know that P1 into V1 is equal to P2 into V2, which is a constant. Now we need to find V2, therefore we'll rearrange this relation to get V2. V2 is equal to P1 into V1 divided by P2. Now we just need to substitute the values of these variables, which will look like this: 760 into 85 divided by 250. And when we solve this, we get 258.4 cc. Therefore, the required volume of the gas is 258.4 cc when the pressure is decreased to 250 millimeter. So this is how we need to solve this type of numericals. Let us try to solve another question which has a different condition. At a particular temperature, a certain quantity of gas occupies a volume of 85 cc at a pressure of 760 millimeter. If the pressure is decreased by 250 millimeter, what will be the volume of the gas at the same temperature? So here the question is almost similar as question number 1. The initial conditions are same. P1 and V1 are same. But here the final condition is little different. Here pressure, the value in digit is same, 250 millimeter, but the condition is little different. Here instead of decreased to, we have decreased by. So this condition gives different final condition in this question. So decreased by means we have to reduce 250 from 760 millimeter to find the final pressure. So let's solve this numerical. Let's write first given conditions. So P1 is 760 millimeter, which is given over here. Now P2 is 760 minus 250, decreased by 250. So when we subtract 250, we get 510 millimeter. Now volume condition is, initial volume is 85 cc. Now we need to find the final volume when the pressure is decreased by 250 millimeter. We know according to Boyle's law, P1 into V1 is equal to P2 into V2, which is a constant. Now since we need to find V2, so we'll just rearrange. So V2 is equal to P1 into V1 divided by P2. Now just substitute these values. 760 into 85 divided by 510. And when we solve this equation, we get 126.67 cc. Therefore, the required volume of the gas is 126.67 cc when the pressure is decreased by 250 millimeter. So before starting solving these type of numericals, we always need to read the question properly and understand the given conditions properly. Then only we should start solving this. Instead of subtracting over here and getting this value, if we start solving this equation by just putting 250 directly instead of writing 510, then we'll get the same answer as in question number 1, which will be wrong in this case. Now let us try to solve another question with little different condition. Question number 3. This is actually question number 3. So at a particular temperature, a certain quantity of gas occupies a volume of 600 cc at a pressure of 700 millimeter. Find under what pressure the volume of the gas will reduce by 20% of the original volume, the temperature remaining constant. So whenever temperature remains constant, we are always talking about Boyle's law, the relation between volume and pressure. So here we have the initial conditions over here of pressure and volume. Now we need to find final pressure, but here the condition of volume is given in terms of reduced by 20% of the original volume. So let us write down the conditions, given conditions first. So V1 is 600 cc, which is the initial volume. Now V2 has been reduced by 20% of the original volume. So 20%, 600 minus 120 gives 480. So how do we get this 120? 20% of initial volume is 120. So 20%. How do you find out 20%? 20 divided by 100 into initial, original volume means initial volume, which is 600. So when we solve this, we get 120. So 20% of the original volume comes to 120. So the final volume has been reduced by 20%. So 600 minus 120 will give us 480 cc. So these are the conditions of volume. Now condition of pressure is, initial pressure is 700 millimeter and we need to find the final pressure when the volume is decreased or reduced by 20% of the original volume. Now we know by Boyle's law, P1 into V1 is equal to P2 into V2, which is a constant. Now just rearrange this relation to get P2. So P2 is equal to P1 into V1 divided by V2. Now substitute the values, we'll get this. And when we solve this numerical or equation, we get 875 millimeter of mercury. So the final answer will be the required pressure is 875 millimeter of mercury in order to reduce pressure by 20% of the original volume. So this is how we solve numericals based on Boyle's law and depending upon different conditions given to us. Based on today's learning, there are 2 questions given to you to solve, and this is your assignment 10. I want you to solve these 2 numericals. There are answers provided to you so that you can verify your solution. Please solve this and send it to me for the timely review. Till we meet next time, stay safe and do all things well.